Hi guys, and welcome to our lesson. Today we are going to talk about nonlinear equations and how to solve them. I'm pretty positive that you guys have already worked with linear equations in your Algebra 1 class where you had to work with solving simultaneous equations, and in there you probably worked with just linear equations. And today we are going to move a little bit ahead of that and work with nonlinear equations and how to solve them. Even if you are totally new to this and you did not work with linear equations and how to solve them before, it's totally fine, because our lesson today, it's going to incorporate methods and concepts that you should have learned from before. So it's going to be more of a review for some of you and more of like a new lesson to some of you, which is totally fine. And our aim for today is obviously how do we solve nonlinear equations algebraically. And our first things first is that we'll work with a do now problem. And a do now problem is actually something we did last week. This is something we always do. We start off our lesson with to kind of like refreshing our memories and minds. This particular do now problem is about complex fractions and how to simplify complex fractions. I'll give you guys about like 4 to 5 minutes to work on this one, and then we will talk about it and work together. So this is actually the do not problem that I had up on our slides. And for this one, the first thing we should be doing is converting all those negative exponents into positive ones. And how do we convert negative exponents into positive ones? Well, what we do is that we write the variable with the negative exponent in its reciprocal form with the positive exponent. So I'm going to go ahead and do that for all the variables with the negative exponents that I see in there. Again, remember, you have to do it for all the negative exponents that you see. As our next step, what we should be doing is nothing newer than simplifying. So now it looks more of like a more known form of complex fractions that we have been seeing from our previous lessons, and not so much of like an awkward form. And now there are actually two ways that you can go about this problem. One of the first ways being that you can either multiply everything, like all the smaller fractions, in the bigger fraction using the LCD, which is the least common denominator of the smaller fraction. Another thing that you can obviously do is that you can simplify the numerator and denominator separately, combine the fractions in the denominator, combine the fractions in the numerator, and then multiply fractions. You can obviously do any of the ways that you're more comfortable doing. What I'm going to do is that I'm going to use the way where you multiply all the smaller fractions using the LCD of the smaller fractions. There's actually like another thing that you can do with this one. You can kind of like simplify this part or this part. You can do some simplification for your numerator because you have like 3 terms in there, but it's fine if you don't want to do it, because either ways you are trying to use the LCD method to save you some time and work, so that you don't have to combine fractions like the classic way kind of does. My LCD is x times x squared. That I found by looking at my denominators of the smaller fractions. So I'm going to multiply everything in there using my LCD. Remember, for the bottom, if you are not combining the fractions and if you still have 3 terms in there, you have to multiply the 3 terms with the LCD 3 times. Try to color code the LCDs so that you guys see how many times I multiplied them with what variable, fractions, and what they were. So now what I should go ahead and do is simplify. So I look at my LCDs and smaller fractions, and if I can get rid of the denominators, because again, this whole point of doing the math in this way is to get rid of the smaller denominators. I'm going to go ahead and look for them. I see one in here that I can cancel. I see another one in here that I can cancel, and another one in here that I can cancel. And now if you take a look, well, bingo, you have gotten rid of all the smaller denominators that you had, and now it looks more of like a simpler fraction where you have a denominator and numerator, which is definitely not fractions. So now I'm going to multiply across whatever I had. So the first one, that should give me x to the third and negative 9x. And then the bottom, I should have x to the third again plus 2x squared minus 3x. Now that you have that, you kind of have to simplify this fraction, and the way you simplify a fraction is by factoring the denominator, factoring the numerator, and then canceling the common factors that you found. Now I was able to do GCF for both the denominator and the numerator, And now what I kind of have to do is that for the first binomial that I have in there, that's actually a special form, difference of two perfect squares. So you can definitely go ahead and do dots. And these are the two factors that you should get if you do that binomial in there. And then for the bottom, it's kind of like interesting because you have a trinomial and you have to do trinomial factoring for that one. And you should end up getting two factors for that part. And your two factors should be x plus 3 and x minus 1. Because plus 3 times minus 1 or plus 3 times negative 1, that gives you negative 3. And plus 3 minus 1, if you subtract, that gives you positive 2. You should be able to find some of the common factors that you can obviously cancel and get rid of. I see this and this in here. Before you go ahead and multiply across, you should also be able to notice that you have x in the top and x in the bottom that you can obviously also cancel. Because again, if you're trying to simplify fractions, you should try to get rid of all the common factors that you see in there that you can cancel at. And after that, whatever you are left with, you kind of multiply across. Well, I have x minus 3 and x minus 1. Notice how that cannot be simplified anymore. That's your final answer. And like I said in the beginning of our lesson, we are going to work with nonlinear equations and how to kind of like solve them, okay? So first off, I want to show you what nonlinear equations kind of look like. Well, if you haven't guessed already, they kind of look like this, right? So they're not linear, they're non-linear. Well, for linear equations, you should be able to write that in the slope-intercept form, which is y is equal to mx plus b, where m is your slope and b is your y-intercept. So that's your slope-intercept form, and you should be always be able to write linear equations in that form. However, if you take a look at this one, you can't write it in that form because your x is squared, right? So now that is what we call nonlinear equations. And even if you have a linear and nonlinear equations, you can obviously solve them. Here's like the most interesting thing about this lesson. That is like, there is no one correct way that you can use to solve this kind of problems. So when it comes to nonlinear equations, you have multiple different ways to approach a problem. As long as you get the correct solution, you are good to go. You can use literally any method that you are more comfortable with and that is more convenient for you. So the first type, and then the most I would say used type of method is substitution. So this is something that we also use for solving simultaneous equations or like solving linear equations. You obviously use substitution. Well, substitution and elimination, they're kind of like the base of all the methods that we use to solve linear or nonlinear equations. All the other methods kind of like stem from them. So we use substitution. The way we kind of will do this is that we're going to do substitution in the most basic form of these equations. So what you kind of have to do is that if you take a look at the bottom, well, right now, the way that these equations are written or formed, you cannot really like substitute one of the equations into the other. And the reason as to why you cannot do that is because signs, right, in here and then in here, you don't have the same thing on both sides of your equal sign. You have different things, right? So you can't really substitute one into the other. And now what you can interestingly do is that you can solve one of the equations for y. So you can write one of these equations in terms of x, or you can write one of these equations in terms of y. So you have to write one of these equations in terms of the other variable, or in other words, you have to solve for one of the variables in one of these equations, and then kind of go from there. So this is what I was kind of like talking about. In this kind of problems, there are like so many flexibilities. Like you can literally like solve for any of the variables in any of the equations and substitute into the other. It does not matter which one you solve for and which variable you solve for. It's only going to make more sense when I walk you through the example in here. So these were my two equations. So what I'm going to go ahead and do is that I'm going to name them. This was equation 1. I'm going to call this equation 2, obviously. Okay. So now if you kind of take a look, something happened in there. So this is exactly the same equation as like equation number 2. And then in that equation, I kind of like solved for a y. So I isolated y, and then I solved for a y in terms of x. It's always kind of like this. So if you're solving for one variable, you have to write that in terms of the other variable. So now y is equal to x minus 14. So I manipulated this equation in there, and then I solved for y. Okay. So now if you take a look at that, so now I kind of know what is y equal to, even though it's in terms of x. So what I'm going to do is that I'm going to go ahead and substitute equation 2, or you can call this one equation 3, which is the manipulated form of equation 2. And then so I'm going to say I'm going to substitute equation 3 into 1. Okay, always try to like kind of manipulate and isolate one of the variables for the equation where you do not have an exponent. So for example, the second one in here, the first one, if you wanted to, you obviously could. But then the second one obviously works better in this case. So now what you can go ahead and do is that you can substitute the value of, not the value, but then you can substitute whatever you solved for y in equation 3 into equation 1. So now instead of writing y, what I'm going to write is this, right? Because I literally told you that y is equal to x minus 14. So instead of writing y, I'm going to write x minus 14, right? And now if you take a look at it, you have in this step, you have only one type of variable, x squared plus parentheses x minus 14 close parentheses is equal to 6. You have only one type of variable, which is x, and you can obviously solve an equation with only one type of variable. All right. So now if you go ahead and then simplify and solve, you should be able to get x is equal to -5 and x is equal to 4. Okay. And now once you get the value of x, you should be plugging those values in to one of the equations to get the value of the other variable. So after I got the value for x, I'm going to go ahead and then plug that in to this equation. Yeah. For your convenience, if you know for a fact that you did this step correctly, you can obviously use that and then plug your value of x in there and then get your y. Again, it's just a plug and then plug and chug kind of. So now for when you plugged in x for 5, you should have gotten x to the -19, like it says in here. And when you plugged in x is equal to 4, you should have gotten -10, like it says in here. Right, and then you can obviously write your answer as solution sets as shown in here. Okay. So now, interestingly enough, but nothing with any surprises, you can use another way to solve the exact same problem. Okay, and in this way, what we're gonna do is that we are gonna isolate for the last problem, right? We actually isolated y in this for this equation. We did not do any manipulations or modifications to that equation. But now what I'm gonna go ahead and do is that I am gonna solve for y in both of my equations. So I'm going to write both of my equations, like equation 1 and equation 2, in terms of, so I'm going to solve for y in both equations 1 and 2 in terms of x. Okay, so this is equation 1, this is equation 2, and then if I'm trying to like solve for y in terms of x, if I'm trying to solve for y in terms of x for equation 1, I should get y is equal to 6 minus x squared. And for equation 2, I should be able to get y is equal to x minus 14. Right? So now if you take a look at this one, now you can do substitution actually. You can substitute either this y using the value of this or this y using the value of this, it doesn't really matter because you are going to get the same thing on both sides of your equal sign. So if I go ahead and substitute, this is exactly what I get. So now if I kind of like, simplify and then try to get all the variables and numbers in one side and set the other one equal to 0, this is what I should get. Right? This is the quadratic equation that I should get. And now let me show you something. Please keep in mind it was x squared plus x minus 20 is equal to 0. Okay? Guess what the equation was in here? The equation in here was exactly the same thing that I showed you in here. X squared plus x minus 20. Right? I did not have to do any of this. I just did, I isolated the variable in like 2 steps, and then I kind of like simplified in this step and then was able to get to this step. So now from there, you should obviously get the same answer, because if you solve for x, you should get the same numerical values. And if you plug that in to one of your equations, you should get the same y values. So do you guys see how it's like, doesn't matter which approach you take, you should always end up getting the same answer if you're doing it correctly, right? So now with more interest and not obviously with more surprise, I have another way that I can use to solve this problem. And this one is another kind of like sister method, I would say, because you have substitution, and obviously with substitution comes elimination, right? I personally, for some reason, prefer elimination over substitution for almost anything. But again, whichever way you are more comfortable with, please do that. And obviously, sometimes for like one particular problem, one way might be more convenient or easier than the other one. Based on that, you obviously pick your method. So if I'm trying to do elimination for this problem, what I'm going to go ahead is that I'm not going to modify, I'm not going to manipulate any of these equations. I will keep them in their original form, and I'm going to go ahead and add these 2 equations. So when I add, well, y minus y, they cancel out, and x squared plus x is equal to 20. And now if I want to bring the 20 to the other side, or if I want to transpose the 20 to the other side, I should get this. Ta-da! And guess what this is? This was exactly the same quadratic equation as we have been seeing from our first problem, right? For your reference, if you go back here, ta-da, magic happened. You have the exact same quadratic equations. And now if you solve, you should obviously get the same answer, like I said before. This was probably the easiest way, or the shortest way that we took to get to our answer. However, elimination is not always going to work. In this one, it worked because you only had 2 types of variables in your 2 equations, and you had like the same variable. Even though they are with the same with different signs, you had the same variable in your 2 equations. So like you have already seen that you can take multiple approaches to do this kind of problems, but if you are like consistent in your way, and if you're doing your math correctly, then you should obviously always end up with the correct answer. So now guess what we are gonna do next? Well, before we go ahead and jump into our practice problems, there's obviously a video in here for your extra help. This video is very much comprehensive in order for you to understand this lesson better. So if at any point you were confused or felt like I rushed over, please watch this video in your own time. And if you have any questions, ask me through my email, or just reach out to us, and then we will explain any of the concepts that you're confused with further, okay? But it's highly recommended that you guys watch this video as part of your extra resources to help you with this lesson. Guess what we are gonna do next? You guessed it right. We are gonna do practice problems because, not surprisingly, Math always gets more beautiful and more amazing with practices, okay? So we're gonna go ahead and do this 3 practice problems better and hope that you guys will be more, comfortable with these problems and be more confident in your method or in your concept that you're trying to use to do these problems, okay? So we're gonna go ahead and see how to solve the first problem first. And again, we are solving for the variables that we see in there, okay? So this is actually our first problem in our practice problem set or list. And for this problem, among the wide range of methods that you can obviously use to solve this one, what I'm going to go ahead and do is that since I see that for both of my equations, equation 1 and equation 2, they are isolated for y. What I'm going to go ahead is that I'm going to substitute. So I'm going to substitute equation 2 into equation 1. It does not matter which one you do. Like I said before, and after you do that, what you should be doing is that you should try to get everything to one side. X squared plus 6x, and I'm going to transpose the 4x and plus 7 to the other side. So then I should get negative 4x minus 7, and obviously you had the negative 8 in there, and then set that equal to 0. And you guessed it right. As your next step, you should be simplifying. Combine the like terms. Well, as my like terms, I see plus 6x and obviously minus 4x, which was placed right beside it. And then I also see this. They are also placed adjacently. So it should not be harder to see the like terms in this equation. And if you combine them, plus 6x minus 4x is plus 2x. And negative 7 minus 8 is negative 15. And now this is a quadratic equation. The two factors that you should be getting is that, again, if you kind of ignore the part that it's an equation, if you kind of think of this as an expression, then you should be able to see that it's a trinomial, right? And the way you kind of factor trinomial is obviously by using trinomial factoring. I taught you this towards the beginning of our sessions. So you should be coming up with your two factors, which are x plus 5 and x minus 3, right? Just to verify, 5 minus 3 gives you plus 2, and 5 times negative 3 gives you negative 15. If you solve for x, you should get x is equal to negative 5 and x is equal to positive 3. And now that you have solved for your x, you go ahead and find your y value by substituting those two values into one of your equations. I'm going to use this one. I apologize, I meant to say this one, but just because it does not have the exponent that the first equation has. So y is equal to 4x plus 7. Well, y should now equal to 4 times instead of x. I'm going to write negative 5 plus 7, and then I'm going to go ahead and simplify that. So now y is equal to negative 13, and again, y is equal to 4x plus 7. You don't have to write the same equation twice. I'm just writing for your understanding. Is equal to 4 times, instead of writing negative 5, I'm going to use 3 plus 7, and then if you simplify, you should get y is equal to 19. And those are the x and then y values that you should get. You can absolutely write them in pairs, or you can just box your answers. I know my boxes are going to turn into prettier boxes than I wanted them to be. But if you wanted to write them as solution pairs, you should obviously pair them correctly. And then the easiest way to kind of see which x value goes with the y value is by noticing here. what did you replace x with to get this y value? I replaced x with -5 to get -13. And then in here, if you take a look, I replaced x with 3 to get 19. And bingo, that's your solution set. And that's that. And then we're going to go ahead and try the second problem now. So for this problem, I'm going to first label them as 1 and 2 so you guys can follow along. And for this problem, again, you have so many different ways to approach this and do this problem. I do not mind, and I don't think anyone else does. So for this one, I think the most convenient and the easiest way to do this one is by using substitution. Again, why? Well, you have y isolated in that equation. In your first equation, you have y is equal to 1 minus 3x, which is like y written in terms of x. So I'm going to go ahead and substitute this y using the value that the question gave me as 1 minus 3x. But please be cautioned that even if you write, so if you're trying to replace y with 1 minus 3x, please do not do this. Please do not do this. Or please do not do this. There are like so many ways this can go wrong, but please do not do any of that. Because guess what? All of those forms are wrong. Those are not actually doing whatever you want it to do, right? So instead, what you should write is this. Use a parenthesis because you are raising that entire binomial to the second power. So that is the correct form, okay? And now what you should be doing is like, nothing new. You should be simplifying. Again, this is a binomial raised to the second power. You can obviously use this formula as a shortcut. And if you wanted to use this formula as a shortcut with my absolutely horrible a, you should write it in this form, a squared minus 2ab plus b squared, where your a is your first term and b is your second term. Well, in this case, 1 is my a and 3x is my b. So I'm going to go ahead and then use this formula kind of to like simplify this binomial. You can also FOIL them if you don't remember the formula off the top of your head. That's totally fine, okay? So that's a squared minus 2 times 3, 6 times 1 is obviously 6, and then x plus 9x squared. Please do not forget that everything that, again, you are making this squared, and this should equal 9x to the second. If you forget that the exponent, then it's totally not the simplified version of this expression in there. So please be mindful of these small mistakes that can make your entire math go wrong, okay? So now I'm gonna set that equal to 1. And from here, it's just all about simplifying. You have to simplify. But obviously, I have a fraction added to this entire part, and I have to get rid of the fraction. And the first step should be finding the common denominator and then kind of like combine all of that. Plus 4 minus 24x plus 36x to the second is equal to 1. Again, from here, what you should do is that you should cross multiply. In cross multiplication, you multiply the denominator of one side using a numerator of the other side and vice versa. Well, since you have 1 in there, this problem should not create that many problems, but just be mindful of that again. So I'm going to simplify this part. And again, the way you simplify that is obviously by combining the like terms, and 36x squared plus x squared, because they are like my like terms, gives me 37x squared. And then in the middle, I have negative 24x. I'm writing this in standard form. Plus 4 is equal to 4. That's what I got when I cross multiplied. I multiplied 1 with 4. Right? And then from there, I should be able to see something. I should be able to see that I have 4 on both sides of my equation, so you can cancel them out. And you're just left with 37x to the second minus 24x is equal to our lovely 0. Now, what do you do next? Well, now you can't really do anything much except you know, kind of like I would say factoring. And the way you factor this out is obviously by using GCF factoring. Well, in here, my GCF is like nothing fancy, but just like the variable x. Right, so now if you solve for x, one of your x's should always equal to 0. And then the other part is 37x minus 24 is equal to 0. X should equal to 24 over 37. Right? Well, for this part, if you're wondering how I got x is equal to 0, what I did was that I saw there was an x here, and there's an x with the 37 inside the parentheses. So now I know that I have to solve for x twice because I see x in 2 places after I factored, right? So now if I'm trying to solve for this x, I have to get rid of this entire binomial from there. And then obviously the way you get rid of the binomial is by dividing both the sides using 37x minus 24, okay? So now, if you divide both the sides using that, you should be able to notice something. Well, obviously in this side, they cancel out, and x is equal to obviously 0 because 0 divided by anything is literally 0, right? Well, now that you have solved for one of the x's in there, you should go ahead and solve for the other x that's kind of like encapsulated between the parentheses. So now we have to do the other thing. So we have to kind of like reverse our way because in our first part, we got rid of this part. And now obviously to solve for this x, I have to get rid of this x in there. And in order for me to get rid of that x, I have to divide both of my sides using x, right? And now if you kind of do that, if you divide both of your sides using x, you should get 37x minus 24 is equal to 0 because again, 0 divided by anything is 0. And now from there, it's literally a linear equation kind of, and then you solve for x, you add 24 to both sides, and then you divide both the sides by using 37, and this is what you get. Okay? Well, now that you have solved for x, you have to go ahead and solve for y. And kind of like to solve for y, what we have to do is that if you take a look, right, you have two equations here. This is your first one, this is your second one, and then you pick one of these equations from here. Obviously, I'm going to pick this one just because, you know, not only is it solved for y, but also it does not have any exponents. So y is equal to 1 minus 3x. That's the equation I am going to use to solve or find the value of y using my x values. So I said y is equal to 1 minus 3x. And obviously, I'm going to use the value of x that I got in there. So then that should give me y is equal to 1 minus 3 times 0. So that solves to be just 1. And in here, obviously, not there. But in here, obviously, if you use 1, y is equal to 1 minus 3x, you should get y is equal to 1 minus 3 times 24 over 37. And if you simplify, you should get negative 35 over 37. Right? That is an improper fraction, so you cannot turn that into mixed fraction. You can just leave it like that. And now again, if you want to write your answers as your solution set, you can definitely do that. And if you do that, you should get keep in mind again, you have to pair them correctly. So when I plugged in 0 for x, I got 1 for y. And when I plugged in 24 over 37 for my x, I got negative 35 over 37 as my y. And that's your solution set for the nonlinear equations that we did in here in this problem. Okay. So now we are going to go ahead and do the third problem. That's the entire problem. If you wanted to take a look or if you want to take a screenshot, go ahead and do it. This was the problem. This was the previous problem. And if you wanted to take a screenshot, go ahead and do it. And now we're going to go ahead and try the third problem. But before we go ahead and do our third problem, something that I wanted to mention is that for this kind of problems, right, you can actually tell if you did them correctly and if you got the correct answer or not, because what you can do is that you can plug both of your x and y value into one of your original equation. Please, for this step, do not use one of your manipulated equations. Use one of your original equations to see if you get the same result when you plug that in as the equation said. Then if you do get the same result, then you obviously have the correct answers or solutions. And if you do not, then try it one more time, okay? So this is obviously our third and last problem from our problem set, practice problem set. And this is a very interesting question because you not only have fractions, but you also have exponents for both of your variables in the second equation. This is something we did not see and work with before, but no worries. Sit tight. We are going to work on this together and solve our way through it. So there are like so many ways that you can use to do this problem. And obviously the way that I'm going to do is that I'm going to isolate one of the variables in the first equation and use substitution to plug that value into equation 2. So I'm going to go ahead and what I'm going to do is that I'm going to isolate for x, right? So I'm going to isolate x. So I'm going to solve x in terms of y. So again, this was xy is equal to 4. And I will obviously have to divide both of my sides using y to get x by itself. Oops, that is totally not what I wanted. Right? And so now you can cancel the y's from that side and x is equal to 4 over y. So now I'm going to call that my equation 3. So now, like I said before, I'm going to plug equation 3 into equation 2. So now I'm going to replace my x with my y. So whatever I got for my, I'm going to replace my x with my, with the value that I got in there, which is in terms of y. So instead of writing x, what I'm going to write is 4 over y raised to the second power. That entire fraction is actually raised to the second power. Please do not forget that. Please do not mess up the exponent. Put that correctly. And then the rest of the equation is obviously going to stay the same. Right? And then from there, what I have to go ahead and do is that simplify. I have to simplify that. The first thing that I'm going to do is that I am going to get rid of this fraction, I'll try to like, that's kind of like a complex fraction. So I'll try to like turn that into a simpler fraction. So, but before I can go ahead and do that, I'll have to get rid of the exponents. It's going to be 16 over y squared over 4 plus y squared over 25 is equal to 1. So now what I have to do is that they're like so in here this was actually the complex fraction. So I have to make the complex fraction into a simpler fraction, and the way I kind of do that is, again, you have to multiply fractions, and then the way you multiply fractions is obviously by doing this. So you do keep, change, flip. I keep the numerator. I change my division into multiplication. And then I flip so I keep my numerator, and I flip, I change the sign into multiplication, and then I flip my denominator. Just like that. Notice how the rest of that equation is kind of like staying the same throughout our process. So in here, now you obviously can try to look for common factors and cancel them. Well, now you obviously see that you can cancel them. And now, well, 16 divided by 4 is 4. And now whatever you have left with, you kind of multiply across. I'm going to make that into a circle. So now you'll try to like multiply across for this parenthesis. Okay? So now if I multiply across, I get 4 over y squared plus y squared over 25 is equal to 1. Well, from here, it's kind of like you are adding fractions. We have worked with them before, so it shouldn't be harder. So the way you add fractions is obviously you create the common denominator. So in here, you have to multiply this fraction using 25 over 25. And obviously, you have to multiply this one using y squared. And that is equal to 1. Okay? So now you have 25y squared as the denominator. And then for this one, if you multiply across, you should get 100 plus y to the 4th is equal to 1. Right, and now if you kind of like, multiply across, you should get 100 plus y to the 4th is equal to 25y squared. Again, I multiplied 25y squared with the 1 in there. And now what you kind of have to do is that you have to bring everything to one side. So I'll have to transpose the 25y squared to the other side. So it's y to the 4th minus 25y squared minus 100 is equal to 0. Now what? What do we do next? Well, you see it's y to the 4th power. And, we have worked with like y to the 2nd power as like our, our variable for the first term, but we never really worked with a variable as part of our first term that has the 4th power as the exponent. Interesting. So what do we have to go ahead and do is that there are like 2 ways to like kind of do this. You can either do use substitution and solve for y from there, or you cannot just like not do it and like, work with the original variables that you have in there. So I will not use substitution. I will work with my original variables that I have in there. So I'm gonna work with it this kind of like the same way I would if I had like a quadratic equation in there. So I go ahead and then find the two numbers that will multiply to negative 100. And if I add those two same numbers, they will add to negative 25. So the two numbers that will actually multiply to negative 100 and those two numbers and then add to negative 25 are actually, I'm going to write the numbers here, are negative 20 and then positive 5. Right? Because if you subtract 5 from so the two numbers that will actually add to negative 25 and will also multiply to negative 100 are actually negative 20 and minus 5, because negative 20 minus 5 gives you negative 25, and exactly negative 20 times negative 5 gives you negative 100, right? I am so sorry, that should have been positive 100, right? So now what I'm going to go ahead and do is that I'm going to write my two factors like I would do if this was a quadratic equation, but instead of using y to the just y, like y minus 20, what I'm going to do is that I'm going to write y to the second power. Because usually when you write like y plus 5 at that, like when you form your two factors as like y plus 5 or like let's say y plus 6, at that time you have a quadratic equation with y to the second power. Because if you take a look at it, if you FOIL this equation, if you multiply, like if you FOIL them, right, the factors, you should get y to the second power and dot 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 as the rest of your expression if you were to FOIL it. So like the same way, you have y to the fourth power in here, so you can no longer use y to the second just y as part of your like factors. You have to use y to the second power, because your original equation that you're trying to factor, that equation is now y to the fourth power, right? So you should be able to see a pattern in there. And you should also be able to see something that will make more sense when we work with it. So I'm going to go ahead and write my two factors in there. Y to the second power minus 20 and y to the second power minus 5. Right, so now if you take a look at them, if you want to FOIL this, if you FOIL this these two factors, you should be able to return to this equation or expression that you FOILed. So now, if you take a look, y squared times y squared gives you y to the fourth, so you know that you did the correct thing. So now what I have to go ahead and do is that I have to solve for y, okay? And if I solve for y, I have to set each of my factors equal to 0. No problem. There. I'm going to do that is equal to 0. And I'm going to set this one equal to 0. So now I'm obviously going to transpose the 20 to the other side. So y squared is equal to 20. Radical both the sides. Y is equal to plus or minus so you can write 20 as 2 times radical 5. This is how it works. Well, 20, you can write them in its multiples. So like 20 is actually 4 times 5. Not 0, obviously. 4 times 5. And you absolutely know that 4 is a perfect square, so you can bring that outside of your radical. So that's going to be 2 times radical 5. So that's how I got 2 times radical 5 for radical 20. And also, every time you like square root something, you get two values, one positive, one negative. Please do not forget that. And in here, I'm going to do the exact same thing, transpose the 5 on the other side, square root both the sides. Y is going to be equal to plus or minus radical 5. I got 4 values of y, and now I know for a fact that I should get 4 values of x if I plug each of those values into an equation. So now we have to go ahead and pick our equation. Interesting. So what I'm going to do is I'm going to pick the first equation right here, just because it's like simpler than the second one. So it's x times y is equal to 4. I can use that as my equation to like plug into my value and then get the y value. Oh. So my equation was xy is equal to 4. I'm gonna use this side for this 2 value and then use this side for these 2 values. So now if I'm trying to solve for x, I should obviously isolate x first. X is equal to 4 over y, as we did for our third equation. And obviously, if I plug in positive 2 over radical 5, I should get for y, I should get x is equal to 4 over 2 radical 5. Well, you can obviously simplify this. You should get x is equal to 1 over radical 5. I mean 2 over radical 5, my bad, because you can obviously cancel the 2 at the bottom and the 4 at the top, and you should be left with 2 over radical 5, which is what I got in there. And now it's your turn to plug in the negative value, and then you know that when you're gonna plug in negative, value for y, you should wind up getting x is equal to the same thing, except it's gonna be negative 2 over radical 5. Because you're doing the same thing, except you're just changing this this positive value of y into a negative one. So you should wind up getting a negative answer. You don't have to repeat the same steps twice. Just keep in mind that these are the 2 values of x that you got when you plugged in your y values from here. So now I'm going to go ahead and then use this side for to find the 2 values of x using these 2 y values. So again, x is equal to 4 over y. So I'm going to replace y with 4 over positive radical 5. Totally not what I wanted. And then x is just going to be equal to 4 over negative radical 5. And then those are actually your 2 answers that you should get. I mean, not 2 answers that you should get when you plug in these 2 y values into this equation, which was manipulated into this equation. And now if you are like an organized person, you obviously would like your answers to be organized as solution sets, and we're going to go ahead and do that. But please keep in mind that you have to like pair them correctly if you are trying to write them as solution sets. So when I plugged in, so in this one, we solved for y first. Please do not put the y values as your x values when you're trying to make the solution set. That is totally going to throw off your hard work that you did to find the values and, do the problem. Please don't do that. Put the x values first, because if you're trying to write a coordinate, the x values always come first. So when I plugged in, I'm going to put the positive one first. 2 over radical 5. This is what I got when I plugged in 2 over radical 5 for y. Even though I worked backwards, I plugged in the y value to get the x. I should be writing the values in the correct order, which is like x comma y. So then when I plugged in negative 2 over radical 5 for y, the x value that I got was -2 over radical 5. And then for this side, so like for my right side now, when I plugged in positive radical 5 for my y, I got 4 over positive radical 5 for my x. Right, and obviously the other x value that I got when I plugged in negative radical 5 was 4 over negative 4 over radical 5. Bingo, as complex as it looks. You got 4 solution sets, so like 2 pairs of x values and 2 pairs of y values. So that's that. This question was like kind of weird and kind of like complex, but again, you know, was it solvable? Did we solve it? Of course we did. We solved for it. We got the answers. But this problem would actually turn into a more complex one if you in this part, if you actually like solved for y in terms of x, this problem would have been a much more complex one. And do you guys know how I know that? Well, I took a look at this part and I saw y squared was like, you know, on top of 25, which is a much bigger denominator than 4. So, you know, try to take a look at the denominators and see whichever fraction has the smaller denominator. Try to like solve for that variable. So when I saw 25 as part of my denominator, then for y, then I kind of like was like, you know what, I'm not going to solve for y. I'm going to go ahead and solve for x and substitute this x value and then go from there. Even in the original problem, I solved for y. As my third equation, I solved for x. So that's kind of like I would say like a trick way, or like you know, like a shortcut method to kind of like help you and not get into a hot mess. Okay. So that's it for today's lesson. I'm obviously going to have the practice problems up on Google Classroom. So, you know, to get more comfortable, to get more confident with this lesson, try to do the practice problems, come up with questions, and we will try to help you. And that is honestly the most, I would say, useful way to get more used to these kind of problems and to get better at them. So that's that. And I will see all of you guys tomorrow at 5 p.m. Take care.